This is Peter and I's robot. So the relationship between the input shaft compared to the output shaft is parallel. And then in gear train A, the speed is constant. And then in gear train B, the speed is increased. And then in gear train A, the torque is increased. No, the torque is constant. And then in gear train B, the torque is decreased. And the gear ratio of gear train A is 1:1. The gear ratio of gear train B is 2:1. And the flow of power is reversible. And then the gears move in the opposite direction of each other. Okay, so this is our simple gear train with idler. The relationship of the input shaft and the output shaft is parallel. So this is the driver, this is the driven, and this is the idler, or the drive. And then the speed is constant, the torque is constant, the gear ratio is 1:1, the flow of power is reversible, the direction of travel, they go the same direction when you turn it on. And then if we took away the idler, they would go in the opposite direction.
The angle of the input shaft compared to the output shaft is perpendicular. The speed increased and the torque decreased. And if the input gear was even larger than the output gear, how would that affect speed and torque? The answer is the speed would increase and the torque would decrease.
This is our worming wheel. The angle of the input shaft compared to the output shaft is perpendicular. The speed is decreased. The torque is increased. The gear ratio is 22:1. The flow of power is not reversible, and the direction of travel is reversible. This is our lead screw. The type of input movement is rotary. The type of output movement is linear. The number of revolutions of the crank it takes to move the screw block 1 inch is 7. The flow of power is not reversible. The force is increased in the output, and the direction of travel is reversible. This is our rack and pinion. The type of input movement is rotary. The type of output movement is linear. If the diameter of the pinion gear was increased, the rack would move shorter. The flow of power is reversible. The direction of travel is reversible. And an example of where this mechanism would be used is a train or a trolley. This is our chain drive. The angle of the input shaft compared to the output shaft is parallel. The speed is increased and the torque is decreased. The input to output ratio is 5:1. What happens to the speed torque gear ratio if the smaller gear becomes the drive gear? The torque is increased, the speed is decreased, and the gear ratio is now 1:5. And then does the input shaft turn in the same opposite direction of the output shaft? It is the same, and the advantage of using a chain drive over spur gears is the chain fits in between the teeth and can go faster. This is our universal joint. The angular range between the input shaft and output shaft is 0 to 32. The speed is constant, the torque is constant, the speed ratio is 1:1, the flow of power is reversible, and the input and output shafts turn in the same direction. This is our cam and follower. The type of input movement is rotary. The type of output movement is reciprocating. The follower moves up and down with one revolution once. The flow of power is not reversible, and the direction of travel is not reversible. The input of the crank and slider is rotary. The output of the crank and slider is reciprocating. The slider moves 7 inches with one revolution of the crank. If the diameter were increased, it'd be longer, and the flow of power is reversible.
No, I mean, there's the universal joint.